You are curious about simple, clean, and evolvable designs and architectures. You have read about Uncle Bob's clean architecture and you have watched his presentation here on YouTube. But when you try to apply these principles to your projects, you get stuck. Then this is just the right video for you. I'm going to show you step by step how to turn theory into practice. Let's get into it. Hello and welcome to this video. A few days ago, I did a code review of an application which aims to follow the principles of clean architecture. While at the first glance these principles seemed to be followed, a closer look revealed that some dependencies did not follow the dependency rule. So I wrote a blog post about how to design a feature following the principles of the clean architecture. The application we are looking at is analyzing test failures from our CI/CD pipeline and is creating defects for our defect database. The specific feature we want to analyze is about sending emails in case something goes wrong in the application. So maybe there's an internal error in the application or some network problem occurred. For the sake of simplicity, in this tutorial we are only looking at this mailing feature. The design of this feature is developed in 4 simple steps, and now it's time to bring this design to life following exactly those steps. Step 1 starts with the business logic. I have already added a project called testfailureanalyzer.core, and I have added a small utility I like to have in my projects, which is helping with design by contract. As all business logic in clean architecture goes into interactors, let's create first of all a new interactor, and we call it mail notification interactor. Create a namespace and the class notification interactor. Let's say our interactor always gets called from outside when something happens in the application which should be notified via email. Let's add APIs for those cases. One case could be internal notify internal error. This error probably occurred while we were processing one test case. So we have the test case ID and the exception which occurred. Another case could be check missing test cases. And we get a build ID. Using over here. Let's implement our first case. In the end, we want to send an email with sufficient information for the receiver. So let's start with an email. We create a new type, new internal error mail. So let's generate that. And this internal error mail will have a sender. It will have, of course, recipients. It will have the test case, which we try to process. It will have the error message. And it will have the stack trace. When we try to build this email, we realize that we are missing information. So we probably need to get some information from outside. Of course, our interactor will not directly talk to any external database, configuration file, or even the email server, but it will interact with the outer world through interfaces. So we need to create some interfaces. Let's have the constructor first. And this constructor takes my configuration reader It takes my test results repository, which provides access to the test results database. Repository, because we are already creating the constructor, let's also already add IL client. Let's generate those interfaces. One, number two, and the last one. The APIs for those interfaces we will create on demand. Of course, we need some members. Private my config reader. We need test results repository, my client. And of course, we need to set those members, my config reader, and test results repository, the mail client. Now let's build the email. Start with the sender, and the sender we get from the configuration reader. Get sender. Okay, let's the mail sender. Then we need the recipients. Again, ask the config reader, get application operators. Then we have the error message, which is exception.message, and the stack trace, which is exception.stacktrace. Finally, we will send the mail through the mail client. I forgot the test case. Test case. Here we get information through the test results repository. Get test details, the test case ID, and here we pick the name of the test case. Now let's generate those APIs. First of all, let's check the configuration reader. It's good. Then test details. Here we need to create another small class, public class test details. And the details of a test case are ID and a name and the assembly and probably much more information, but this is not relevant for this tutorial, so let's keep it like that. Finally, to create also the send API. Let's check this one. It's great. Now let's do the same with the second case. Let's copy that code. The second case is about missing test cases. So let's assume we somehow detected some more business logic here to detect there's a network issue. Then we send a network failure mail. Let's create that one as well. Okay. Of course, we need a sender again and a few recipients, but this time we need build ID. And let's say we somehow also figure out the test agents which were affected. Test agents. So let's build up this email here. Build ID. And we get the test agents. And for this, we skip the business logic again to keep the tutorial short. Also, we need another API here. Let's do this manually. And we have a network failure mail. Looks like we need to make those classes public. Okay. So we are done with the first step. All the business logic is in the interactor. We have defined interfaces in the business logic layer to interact with the outer world, and we created specific response objects which will be passed to the mail client. In step 2, we want to communicate with the outer world. So we create a new project. This will be class library, C#, and we will call it test failure.io. This project will host the implementations of the interfaces we have created. So let's add here test database add configuration reader, and we add email client. We need a namespace test failure analyzer.io, and we create mail client implementing I client. Let's keep this empty for now. Same with the configuration reader. Space public class configuration reader implements I configuration reader. Implement this one empty as well. Let's return null just to make the compiler happy. And the same again, the test database client, namespace public class test database client implementing I test results repository. The implementation of these classes will later access the outer world. So the test database client would use, for example, SQL to really access a database. The configuration reader might read some XML file or some JSON file to really do I/O. And the mail client, of course, would really talk to the mail server, sending really SMTP emails. And we have now separated all those details into a separate project, and we keep now all our business logic completely independent of these things. For step 2, there is now only one thing missing, which is the component which composes all these things together. In clean architecture, we call this component the main component. As this application is a command line application, we will put it into the command line project. So let's add another project here. It will be a console application, C# again, and we will call it test analyzer.cli. Let's sketch here how we would compose now the things together. So we would create a mail client, create the test results repository, which is the test database client, and we need the config reader, which is the configuration reader. need using, and finally we need our interactor, which is the mail notification interactor. And this one now gets configuration reader, config, gets the test results repository, and finally the mail client. So we can see it's only this single component which knows all the ugly details, how the application is composed together and what are the implementations of specific interfaces. We are done with step 2. In step 3, we want to look at a detail which we ignored so far. Which component is actually formatting the email? In the business logic, we have created nice data structures containing all the relevant information for an email. But which component is actually formatting the email body? Now let's assume we do not want to create ASCII email bodies, but really nice formatted HTML email bodies. This would clearly not be the job of the business logic. We could put it into the mail client, which we have placed in the IO project. But actually in clean architecture, we want to have as less code as possible in that frameworks layer. The correct location for this kind of code in the clean architecture would be the adapters layer. So let's create another project. It will be a library, C#, and we will call it test analyzer.adapters. In the adapters layer, we will create a new class, which we call mail client adapter. So this mail client adapter will now implement iMail client from the business logic, and it will create HTML emails. So let's create one, mail HTML mail. Let's generate the class. This HTML email will now only have a sender, HTML sender, which we get from the input mail, and we need the recipients, which we also just forward, and we have a body which will be HTML. So let's just write some simple HTML here. Of course, in the real implementation, we could work with templates, for example. And now this mail client adapter will talk to the actual mail client. This, of course, means we need another interface, an interface which can now be implemented by the original mail client and which takes the HTML email. And this interface we will add here. iMail client. This interface takes the HTML email. Of course, now clearly state that here we implement iMail client from the core project. Let's fix this here, test, nicer. And of course we need a constructor, client adapter, and here we take the mail client we just defined, client. And of course we also need a member. And now we still need to get those properties. And now we also need to change the original mail client to no longer implement iMail client from the core project, but the one, the adapters layer. Let's go back to the adapter. And of course, we should now add a lot of code here to really take all the data from the mail we got from the core project to actually format a nice HTML body. So just as an example, we put here dot error message. Of course, we also need to change our program. So we have the mail client. Now also need the mail client adapter. Client, client adapter, which takes the client it is using here. And of course, our interactor now takes the adapter. So in our interactor, we do all the decision making and all the business logic. Interactor will call the mail client adapter. The mail client adapter will do all the HTML formatting and will then call the actual mail client, which will then just take the HTML email, convert it into a data structure which the external framework requires to finally really send an SMTP email through email server. And now we are done with step 3. The last step, we will add test cases for our feature. So let's create another project. And a project, it will a unit test project, C#, and we will call it test failure analyzer tests. Fail notification tests. Now let's write a test case which tests the internal error email. Turn or is notified fail. Okay, so we would like to call our system, trigger an error, and verify content of the email. So how would we do this? One way would be to call our interactor directly and work with the nice data structures we have created. But this would mean that we couple our test cases to the internal design of the application. In clean architecture, we try to avoid this. Instead, we create a test API, which is specifically designed as a kind of anti-corruption layer between the test cases and the application itself. This test API we would put into the adapters layer so that we do not only test the business logic, but can also test the adapters. And with this, we achieve a higher coverage. So let's create this API. We go to our adapters layer, file, test API. And in order to keep it simple, let's just create a public static API. Public static, return here the HTML email, simulate, turn error word. So obviously we would call our adapter here, mail client adapter. This mail client adapter takes a mail client. We will pass a fake client here so that we avoid any I/O with external systems and can also get the HTML email and return it. Of course, we have to create this fake client. Let's create it as a private class here. This one needs to implement mail client from adapters layer. And it just provides access to the HTML email. So we give a property here. and whatever gets passed here, we will remember. And then we can turn mail from the mail client. Of course, we also need our interactor. Mail client, mail notification interactor. It requires the config reader. It requires the test results repository and our adapter. Let's rename it. Okay. And of course, we would need some fake implementations for the config reader and for the test results repository as well. Let's create some dummy implementations here. Private class fake reader. It's the config reader. Then private class test database. Test results repository. And let's pass those here. Config reader, new test database. And now we can call our interactor here, interactor dot define internal error. Let's give some dummy test case ID here, 42, and some exception. New exception. Well, actually, it would be nicer if the exception would come from outside the test case. So let's this exception here. Using is missing. With this test API, our tests do not need to know anything about our internal design. It doesn't need to know about those clients. It doesn't need to know about the interactor, its AP surface, and so on. It can interact with the system in a pretty simple and convenient way. So now let's get back to our test case. So we will call our test API here, and we will pass some, let's say, lead information exception. Oops. Okay, some using is missing. Let's first add this one. And we need using test analyzer dot adapters. We need to add the project reference. And runs to the adapters. So we trigger our system here, we pass an error, and we get a mail back. And we could now add some asserts like assert that mail body contains substring. Oops. Of course, we would add some more asserts here just to sketch how it could be implemented. And with this, we are also done with the last step. We are done. Skeleton of the feature is implemented following the principles and the rules of the clean architecture. If you liked the video, support it with a thumbs up. Do you have questions or suggestions to the design or the implementation? Leave a comment below. See you in the next video.